The Origin of Species by Means of Natural Selection by Charles Darwin. Read for LibriVox.org by Michael Armenta. Chapter 3. Struggle for Existence. Geometrical Ratio of Increase. A struggle for existence inevitably follows from the high rate at which all organic beings tend to increase. Every being, which during its natural lifetime produces several eggs or seeds, must suffer destruction during some period of its life, and during some season, or occasional year. Otherwise, on the principle of geometrical increase, its numbers would quickly become so inordinately great that no country could support the product. Hence, as more individuals are produced than can possibly survive, there must in every case be a struggle for existence, either one individual with another of the same species, or with the individuals of distinct species, or with the physical conditions of life. It is the doctrine of Malthus, applied with manifold force to the whole animal and vegetable kingdoms, for in this case there can be no artificial increase of food, and no prudential restraint from marriage, although some species may be now increasing more or less rapidly in numbers. All cannot do so, for the world would not hold them. There is no exception to the rule that every organic being naturally increases at so high a rate that, if not destroyed, the earth would soon be covered by the progeny of a single pair. Even slow-breeding man has doubled in 25 years, and at this rate, in less than 1,000 years, there would literally not be standing room for his progeny. Linnaeus has calculated that if an annual plant produced only 2 seeds, and there is no plant so unproductive as this, and their seedlings next year produced 2, and so on, then in 20 years there would be 1,000,000 plants. The elephant is reckoned the slowest breeder of all known animals, and I have taken some pains to estimate its probable minimum rate of natural increase. It will be safest to assume that it begins breeding when 30 years old, and goes on breeding till 90 years old, bringing forth 6 young in the interval, and surviving till 100 years old. If this be so, after a period of from 740 to 750 years, there would be nearly 19 million elephants alive, descended from the first pair. But we have better evidence on this subject than mere theoretical calculations, namely, the numerous recorded cases of the astonishingly rapid increase of various animals in a state of nature, when circumstances have been favorable to them during 2 or 3 following seasons. Still more striking is the evidence from our domestic animals of many kinds which have run wild in several parts of the world. If the statements of the rate of increase of slow-breeding cattle and horses in South America, and latterly in Australia, had not been well authenticated, would have been incredible. So it is with plants. Cases could be given of introduced plants which have become common throughout whole islands in a period of less than 10 years. Several of the plants, such as the cardoon and tall thistle, which are now the commonest over the wide plains of La Plata, clothing square leagues of surface, almost to the exclusion of every other plant, have been introduced from Europe. And there are plants which now range in India, as I hear from Dr. Falconer, from Cape Comorin to the Himalaya, which have been imported from America since its discovery. In such cases, and endless others could be given, no one supposes that the fertility of the animals or plants has been suddenly and temporarily increased in any sensible degree. The obvious explanation is that the conditions of life have been highly favorable, and that there has consequently been less destruction of the old and young, and that nearly all the young have been enabled to breed. Their geometrical ratio of increase, the result of which never fails to be surprising, simply explains their extraordinarily rapid increase and wide diffusion in their new homes. In a state of nature, almost every full-grown plant annually produces seed, and among animals there are very few which do not annually pair. Hence, we may confidently assert that all plants and animals are tending to increase at a geometrical ratio, that all would rapidly stock every station in which they could, anyhow, exist, and that this geometrical tendency to increase must be checked by destruction at some period of life. Our familiarity with the larger domestic animals tends, I think, to mislead us. We see no great destruction falling on them, and we do not keep in mind that thousands are annually slaughtered for food, and that in a state of nature an equal number would have somehow to be disposed of. The only difference between organisms which annually produce eggs or seeds by the thousand, and those which produce extremely few, is that the slow breeders would require a few more years to people, under favorable conditions, a whole district, let it be ever so large. The condor lays a couple of eggs, and the ostrich a score, and yet in the same country the condor may be the more numerous of the two. The fulmar petrel lays but one egg, yet it is believed to be the most numerous bird in the world. One fly deposits hundreds of eggs, and another, like the hippobosca, a single one. But this difference does not determine how many individuals of the two species can be supported in a district. A large number of eggs is of some importance to those species which depend on a fluctuating amount of food, for it allows them rapidly to increase in number. But the real importance of a large number of eggs or seeds is to make up for much destruction at some period of life, and this period, in the great majority of cases, is an early one. If an animal can in any way protect its own eggs or young, a small number may be produced, and yet the average stock be fully kept up. But if many eggs or young are destroyed, many must be produced, or the species will become extinct. It would suffice to keep up the full number of a tree which lived on an average for 1,000 years, if a single seed were produced once in 1,000 years, supposing that this seed were never destroyed and could be ensured to germinate in a fitting place. So that in all cases the average number of any animal or plant depends only indirectly on the number of its eggs or seeds. In looking at nature, it is most necessary to keep the foregoing considerations always in mind, never to forget that every single organic being may be said to be striving to the utmost to increase in numbers, that each lives by a struggle at some period of its life, that heavy destruction inevitably falls either on the young or old during each generation, or at recurrent intervals. Lighten any check, mitigate the destruction ever so little, and the number of the species will almost instantaneously increase to any amount. Nature of the checks to increase. The causes which check the natural tendency of each species to increase are the most obscure. Look at the most vigorous species. By as much as it swarms in numbers, by so much will it tend to increase still further. We know not exactly what the checks are, even in a single instance, nor will this surprise anyone who reflects how ignorant we are on this head, even in regard to mankind, although so incomparably better known than any other animal. This subject of the checks to increase have been ably treated by several authors, and I hope in a future work to discuss it at considerable length, more especially in regard to the feral animals of South America. Here I will make only a few remarks, just to recall to the reader's mind some of the chief points. Eggs, our very young animals, seem generally to suffer most, but this is not invariably the case. With plants there is a vast destruction of seeds, but from some observations which I have made, it appears that the seedlings suffer most from germinating in ground already thickly stocked with other plants. Already thickly stocked with other plants. Seedlings also are destroyed in the vast numbers by various enemies. For instance, on a piece of ground 3 feet long and 2 wide, dug and cleared, and where there could be no choking from other plants, I marked all the seedlings from our native weeds as they came up, and out of 357, no less than 295 were destroyed, chiefly by slugs and insects. If turf which has long been mown, and the case would be the same with turf closely browsed by quadrupeds, be let to grow, the more vigorous plants gradually kill the less vigorous, though fully grown plants. Thus, out of 20 species grown on a little plot of mown turf, 3 feet by 4, 9 species perished, from the other species being allowed to grow up freely. The amount of food for each species, of course, gives the extreme limit to which each can survive, but very frequently it is not the obtaining food, but the serving as prey to other animals, which determines the average number of a species. Thus there seems to be little doubt that the stock of partridges, grouse, and hares on any large estate depends chiefly on the destruction of vermin. If not one head of game were shot during the next 20 years in England, and at the same time, if no vermin were destroyed, there would, in all probability, be less game than at present, although hundreds of thousands of game animals are now annually shot. On the other hand, in some cases, as with the elephant, none are destroyed by beasts of prey, for even the tiger in India most rarely dares to attack a young elephant protected by its dam. Climate plays an important part in determining the average numbers of a species, and periodical seasons of extreme cold or drought seem to be the most effective of all checks. I estimated, chiefly from the greatly reduced numbers of nests in the spring, that the winter of 1854-5 destroyed 4/5 of the birds in my own grounds, and this is a tremendous destruction when we remember that 10% is an extraordinarily severe mortality rate from epidemics with man. The action of climate seems at first sight to be quite independent of the struggle for existence, but in so far as climate chiefly acts in reducing food, it brings on the most severe struggle between the individuals, whether of the same or of distinct species, which subsist on the same kind of food, even when climate, for instance, extreme cold, acts directly. For instance, extreme cold acts directly, it will be the least vigorous individuals, or those which have got least food through the advancing winter, which will suffer the most. When we travel from south to north, or from a damp region to a dry, we invariably see some species gradually getting rarer, and finally disappearing. And the change of climate being conspicuous, we are tempted to attribute the whole effect to its direct action. But this is a false view. We forget that each species, even where it most abounds, is constantly suffering enormous destruction at some period of its life from enemies or from competitors for the same place and food, and if these enemies or competitors be in the least degree favored by any slight change of climate, they will increase in numbers, and as each area is already fully stocked with inhabitants, the other species must decrease. When we travel southward and see a species decreasing in numbers, we may feel sure that the cause lies quite as much in other species being favored, as in this one being hurt. So it is when we travel northward, but in a somewhat lesser degree, for the number of species of all kinds, and therefore of competitors, decreases northward. Hence, in going northward, or in ascending a mountain, we far oftener meet with stunted forms due to the directly injurious action of climate than we do in proceeding southward or in descending a mountain. When we reach the Arctic regions, or snow-capped summits, or absolute deserts, the struggle for life is almost exclusively with the elements. That climate acts, in main part, indirectly by favoring other species, we clearly see in a prodigious number of plants, which in our gardens can perfectly well endure our climate, but which never become naturalized, for they cannot compete with our native plants, nor resist destruction by our native animals. When a species, owing to highly favorable circumstances, increase inordinately in numbers in a small tract, epidemics, at least this seems generally to occur with our game animals, often ensue, and here we have a limiting check independent of the struggle for life. But even some of these so-called epidemics appear to be due to parasitic worms, which have, from some cause, possibly in part through facility of diffusion among the crowded animals, been disproportionately favored. And here comes in a sort of struggle between the parasite and its prey. On the other hand, in many cases, a large stock of individuals of the same species, relatively to the number of its enemies, is absolutely necessary for its preservation. On the other hand, in many cases, a large stock of individuals of the same species, relatively to the number of its enemies, is absolutely necessary for its preservation. Thus we can easily raise plenty of corn and rapeseed, etc., in our fields, because the seeds are in great excess compared with the number of birds which feed on them. Nor can the birds, though having a superabundance of food, at this one season, increase in number proportionally to the supply of seed, as their numbers are checked during the winter. But anyone who has tried knows how troublesome it is to get seed from a few wheat or other such plants in a garden. I have, in this case, lost every single seed. This view of the necessity of a large stock of the same species for its preservation explains, I believe, some singular facts in nature, such as that of very rare plants being sometimes extremely abundant in the few spots where they do exist, and that of some social plants being social, that is, abounding in individuals, even on the extreme verge of their range. For in such cases we may believe that a plant could exist only where the conditions of its life were so favorable that many could exist together, and thus save the species from utter destruction. I should add that the good effects of intercrossing and the ill effects of close interbreeding no doubt come into play in many of these cases, but I will not here enlarge on this subject. Complex relations of all animals and plants to each other in the struggle for existence. Many cases are on record showing how complex and unexpected are the checks and relations between organic beings, which have to struggle together in the same country. I will only give a single instance, which, though a simple one, interested me. In Staffordshire, on the estate of a relation, where I had ample means of investigation, there was a large and extremely barren heath, which had never been touched by the hand of man. But several hundred acres of exactly the same nature had been enclosed 25 years previously, and planted with Scotch fir. The change in the native vegetation of the planted parts of the heath was most remarkable, more than is generally seen in passing from one quite different soil to another. Not only the proportional numbers of the heath plants were wholly changed, but 12 species of plants, not counting grasses and carices, flourished in the plantations which could not be found on the heath. The effect on the insects must have been still greater, for 6 insectivorous birds were very common in the plantations, which were not to be seen on the heath. And the heath was frequented by 2 or 3 distinct insectivorous birds. Here we see how potent has been the effect of the introduction of a single tree, nothing whatever else having been done, with the exception of the land having been enclosed so that cattle could not enter. But how important an element enclosure is, I plainly saw near Farnham, in Surrey. Here there are extensive heaths, with a few clumps of old Scotch firs on the distant hilltops. Within the last 10 years large spaces have been enclosed, and self-sown firs are now springing up in multitudes, so close together that all cannot live. When I ascertained that these young trees had not been sown or planted, I was so much surprised at their number that I went to several points of view, whence I could examine hundreds of acres in the unenclosed heath, and literally I could not see a single Scotch fir, except the old planted clumps. But on looking closely between the stems of the heath, I found a multitude of seedlings and little trees which had been perpetually browsed down by the cattle. In one square yard, at a point some 100 yards distant from one of the old clumps, I counted 32 little trees, and one of them, with 26 rings of growth, had, during many years, tried to raise its head above the stems of the heath, and had failed. No wonder that as soon as the land was enclosed, it became thickly clothed with vigorously growing young firs. Yet the heath was so extremely barren and so extensive that no one would ever have imagined that cattle would have so closely and effectually searched it for food. Here we see that cattle absolutely determined the existence of the Scotch fir, but in several parts of the world, insects determined the existence of cattle. Perhaps Paraguay offers the most curious instance of this, for here neither cattle, nor horses, nor dogs have ever run wild, though they swarm southward and northward in a feral state. And Azara and Reniger have shown that this is caused by the greater number, in Paraguay, of a certain fly which lays its eggs in the navels of these animals when first born. The increase of these flies, numerous as they are, must be habitually checked by some means, probably by other parasitic insects. Hence, if certain insectivorous birds were to decrease in Paraguay, the parasitic insects would probably increase, and this would lessen the number of the navel-frequenting flies. Then cattle and horses would become feral, and this would certainly greatly alter, as indeed I have observed in the parts of South America, the vegetation. This again would largely affect the insects, and this, as we have just seen, in Staffordshire, the insectivorous birds, and so onwards in ever-increasing circles of complexity. Not that under nature the relations will ever be as simple as this. Battle within battle must be continually recurring with varying success, and yet in the long run the forces are so nicely balanced that the face of nature remains for long periods of time uniform, though assuredly the merest trifle would give the victory to one organic being over another. Nevertheless, so profound is our ignorance, and so high our presumption, that we marvel when we hear of the extinction of an organic being, and, as we do not see the cause, we invoke cataclysms to desolate the world, or invent laws on the duration of the forms of life. I'm tempted to give one more instance showing how plants and animals, remote in the scale of nature, are bound together by a web of complex relations. I shall, hereafter, have occasion to show that the exotic Lobelia fulgens is never visited in my garden by insects, and consequently, from its peculiar structure, never sets a seed. Nearly all our orchidaceous plants absolutely require the visits of insects to remove their pollen masses, and thus to fertilize them. I find, from experiments, that humble bees are almost indispensable to the fertilization of the heartsease, Viola tricolor, for other bees do not visit this flower. I have also found that the visits of bees are necessary for the fertilization of some kinds of clover. For instance, 20 heads of Dutch clover, Trifolium repens, yielded 2,290 seeds, but 20 other heads, protected from bees, produced not one. Again, 100 heads of red clover, T. praetens, produced 2,700 seeds, but the same number of protected heads produced not a single seed. Humble bees alone visit red clover, as other bees cannot reach the nectar. It has been suggested that moths may fertilize the clovers, but I doubt whether they could do so in the case of the red clover, from their weight not being sufficient to depress the wing petals. Hence we may infer as highly probable that if the whole genus of humble bees became extinct or very rare in England, the heartsease and the red clover would become very rare, or wholly disappear. The number of humble bees in any district depends in a great measure upon the number of field mice, which destroy their combs and nests. And Colonel Newman, who has long attended to the habits of humble bees, believes that, quote, more than 2/3 of them are thus destroyed all over England. End quote. Now, the number of mice is largely dependent, as everyone knows, on the number of cats, and Colonel Newman says, quote, near villages and small towns I have found the nests of humble bees more numerous than elsewhere, which I attribute to the number of cats that destroy the mice. End quote. Hence it is quite credible that the presence of a feline animal in large numbers in a district might determine, through the intervention first of mice and then of bees, the frequency of certain flowers in that district. In the case of every species, many different checks, acting at different periods of life, and during different seasons or years, probably come into play. Some one check, or some few, being generally the most potent, but all will concur in determining the average number, or even the existence of the species. In some cases it can be shown that widely different checks act on the same species in different districts. When we look at the plants and bushes clothing an entangled bank, we are tempted to attribute their proportional numbers and kinds to what we call chance. But how false a view is this? Everyone has heard that when an American forest is cut down, a very different vegetation springs up. But it has been observed that ancient Indian ruins in the southern United States, which must formerly have been cleared of trees, now display the same beautiful diversity and proportion of kinds as in the surrounding virgin forests. What a struggle must have gone on during long centuries between the several kinds of trees, each annually scattering its seeds by the thousand. What war between insects and insects, between insects, snails, and other animals, with birds and beasts of prey, all striving to increase, all feeding on each other, or on the trees, their trees and seedlings, or on the other plants which first clothed the ground, and thus checked the growth of the trees. Throw up a handful of feathers, and all fall to the ground according to definite laws. But how simple is the problem where each shall fall, compared to that of the action and reaction, the innumerable plants and animals which have determined, in the course of centuries, the proportional numbers and kinds of trees now growing on the old Indian ruins. The dependency of one organic being on another, as of a parasite on its prey, lies generally between beings remote in the scale of nature. This is likewise sometimes the case with those which may strictly be said to struggle with each other for existence, as in the case of locusts and grass-feeding quadrupeds. But the struggle will almost invariably be most severe between the individuals of the same species, for they frequent the same districts, require the same food, and are exposed to the same dangers. In the case of varieties of the same species, the struggle will generally be almost equally severe, and we sometimes see the contest soon decided. For instance, if several varieties of wheat be sown together, and the mixed seed be re-sown, some of the varieties, which best suit the soil or climate, or are naturally the most fertile, will beat the others and so yield more seed, and will, consequently, in a few years, supplant the other varieties. To keep a mixed stock of even such extremely close varieties as the various colored sweet peas, they must be, each year harvested separately, and the seed then mixed in due proportion. Otherwise, the weaker kinds will steadily decrease in number and disappear. So again with the varieties of sheep. It has been asserted that certain mountain varieties will starve out other mountain varieties, so that they cannot be kept together. The same result has followed from keeping together different varieties of the medicinal leech. It may even be doubted whether the varieties of any of our domestic plants or animals have so exactly the same strength, habits, and constitution, that the original proportions of a mixed stock, crossing being prevented, could be kept up for half a dozen generations if they were allowed to struggle together in the same manner as beings in a state of nature, if they were allowed to struggle together in the same manner as beings in a state of nature, and if the seed or young were not annually preserved in due proportion.